Let us spend some time looking at recursive formulas for geometric sequences. The focus of this topic is just going to look at the steps that we need to follow to arrive at this recursive formula. Now let's look at the steps. We're going to start by identifying the first term, which is a, and then we're going to identify a common ratio between each successive term, and then we're going to write the formula in this form. Here is something to take note of. We have a as the first term when n is equal to 1, and for every successive term you're going to multiply the common ratio to the previous term. So let's look at some examples and apply these steps. So we have this table where we're told that this is a geometric sequence. So the best way to find out is you're always going to go from right to left. We're going to divide the value on the right by the previous value on the left. So 4 divided by 8, 2 divided by 4, 1 divided by 2, 1/2 divided by 1. So we have a as our first term, and our common ratio is 1/2. So we're going to write our recursive formula as follows. Actually, a is equal to 8. Avoid making that error. You want to focus on the f of n, not on n. So a is equal to 8. So 8. And then our common ratio is 1/2 multiplied by f of n minus 1. So 8 when n equal to 1, and this is when n is greater than 1. Always remember that n can only be a whole number. So let's look at this example here. In this example, we want to find out, well, we know what our a is. Our a is equal to 3. And our ratio, let's go ahead and identify what our ratio is. -9 divided by 3, that's -3. 27 divided by -9 is -3. Here we also have -3, and 243 divided by -81 is -3. So our function, let's go ahead and create our curly braces. So our first term is 3, and then we have our ratio is -3 multiplied by f of n minus 1. So we're going to multiply -3 by the previous term. So we have 3 when n equal to 1, and we have this when n is greater than 1. So just an error that is easy to make, and I've made the error here. What we're going to do is we're actually not dealing with f of n, we're dealing with g of n. So let's correct that. So this is g of n, this is g of n minus 1. So now we want to look for g of 6. G of 6, as we said earlier, is going to be -3 multiplied by g of 5, which is -3 multiplied by 243, and when you go through the computation, you get -729. Final example, we want to find out what a is. A is 1/3. And we want to find a common difference, so we go from the right to the left. 2/3 divided by 1/3, 1/3 divided by 2/3, and so on and so forth. So let's find the ratio here. Ratio is 2/3 divided by 1/3, which is 2/3 times 3/1. This is 2. So your ratio is equal to 2. So our function is going to end up looking like this. Avoid this error. We're dealing with p here, so it's p of n is equal to, let's create our curly braces. Our first term is 1/3, and every successive term we're multiplying 2 by the previous term. So this is when n equal to 1, this is when n is greater than 1. So we want to find p of 7. P of 7 is 2 multiplied by P of 6. And we don't know what P of 6 is because we only have P of 5. So this is going to be 2 multiplied by 2 multiplied by P of 5. So this is 4 multiplied by 5 1/3. So let's go over here where we have some space. So we have 4 multiplied by 5 1/3 is 16 over 3. So this is going to give us 64 over 3. And we have, show you a simple way to go about this is 64 divided by 3. We have 2, 6, 4, 1. So we have 1. So we have 21 1/3. So P of 7 is 21 1/3.